Welcome back. We started solving this question in the previous video. We completed this table for the relation h is equal to 26t minus 5t squared. In this video, we are going to use the values of t and h in this table to draw the graph of the relation h is equal to 26t minus 5t squared on a graph sheet. So, we are going to use a scale of 2 centimeters to 1 second on the t-axis and 2 centimeters to 5 meters on the h-axis to draw the graph of the relation h is equal to 26t minus 5t squared on a graph sheet. Then after that, we will use the graph to estimate I, the greatest height reached by the stone, II, the time it took the stone to reach that greatest height, and III, the time it took the stone to hit the ground. So let's begin by drawing the graph of the relation h is equal to 26t minus 5t squared on the graph sheet. Before we do that, let's consider something. In all the previous examples that we have solved, we can see that the variables in the relation given to us were x and y. So for example, in this relation, h would have been y and t here would have been x. In that case, we will have something like this. Y is equal to 26x minus 5x squared. But in this relation given to us, the variables are h and t. Let's compare this to when the variables are y and x. If the variables are y and x, we will have y is equal to 26x minus 5x squared. The variables here are h and t, so we have h is equal to 26t minus 5t squared. We can see that y is now h and x is now t. So if the question says t-axis, it is referring to the x-axis because x is t. And if the question says h-axis, it is referring to the y-axis. So the question says that we should draw the graph of the relation h is equal to 26t minus 5t squared using a scale of 2 centimeters to 1 second on the t-axis, which is the x-axis that we normally use, and 2 centimeters to 5 meters on the h-axis, which is the y-axis that we normally use. So the t-axis will be the x-axis and the h-axis will be the y-axis. In the question, we were told that the time t is in seconds. So on the t-axis, the scale will be 2 centimeters to 1 second. Usually when we are quoting the scale on the x-axis, we say 2 centimeters to 1 unit or 2 centimeters to 2 units. This is because we don't know the units of x. But here, t is in seconds, so we know the unit of t. So the scale given to us is 2 centimeters to 1 second. In the same way on the h-axis, the time is in meters, so we know the units of h. So on the h-axis, the scale given to us is 2 centimeters to 5 meters. I hope that is clear now. So we are going to use a scale of 2 centimeters to 1 second on the t-axis, which will be the x-axis, and 2 centimeters to 5 meters on the h-axis, which will be the y-axis, to draw the graph of the relation h is equal to 26t minus 5t squared. Let's do that. So this is the graph, and these are the set of t and h values we are going to plot. The scale we are going to use on the graph is 2 centimeters to 1 second on the t-axis and 2 centimeters to 5 meters on the h-axis. Remember that we said the t-axis will be the x-axis and the h-axis will be the y-axis. Looking at these values, I'm going to choose this vertical major grade line as my h-axis and this horizontal major grade line as my t-axis. They meet at this point, so here will be the origin, which is 0. The scale on the t-axis is 2 centimeters to 1 second. So I'll use a scale of 2 centimeters to 1 second to number the t-axis. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'll use a scale of 2 centimeters to 5 meters to number the h-axis. So I have 0, 5, 10, 15, 20, 25, 30, 35 on the positive side. Then on the negative side, you have minus 5, minus 10, minus 15, minus 20, minus 25. So you have now numbered both the t and h axis using the scale given to us. Let's plot the points. The first point is 0, 0. So we have 0, 0 here. The next point is 1, 21. So 1 on the t-axis and 21 on the h-axis, which fall on this point. The next one is 2, 32. So 2 on the t-axis, 32 on the h-axis, which fall on this point. The next one is 3, 33. So 3 on the t-axis and 33 on the h-axis, and it falls on this point. The next one is 4, 24. So 4 on the t-axis and 24 on the h-axis, and it falls on this point. The next one is 5, 5. So 5 on the t-axis and 5 on the h-axis, and it falls on this point. The next one is 6 minus 24. So 6 on the t-axis minus 24 on the h-axis, and it falls on this point. We can see that most of these points does not fall on the major grid line. We have learned how to locate a point that does not fall on the major grid line in the videos on plotting points on a graph sheet, which is the video number 16 in this playlist. So if you want to learn more about how to locate a point that does not fall on the major grid line, please watch the video number 16 in this playlist. Let's continue with the solution. So after you have plotted the points, we join them with our free hand to get the graph of the relation h is equal to 26t minus 5t squared. Now, let's move on to the next part of the question. It says that we should find the greatest height reached by the stone. In the question, we are told that a stone is projected into the air from the ground. The starting point of the stone will be at the origin. We are going to use this red dot to represent the stone. At the origin, the height of the stone is 0 and the time is also 0. So the origin will be the starting point. It means that this horizontal major grid line, which is the t-axis, represents the ground. So at this point, we can say that the stone is on the ground. From the question, we are told that the stone was projected into the air. That is, it was thrown into the air. And we have seen from the illustration we considered in the previous video that when we project the stone into the air, it will travel through the air and reach a certain greatest height. So when we project the stone into the air, it will travel and reach a certain greatest height, which will be at this point. At this point, we can find the height of the stone by tracing it to the h-axis. So we trace this point to the h-axis and we read the value of h here, which is given as 34 on my graph sheet. So on my graph sheet, the greatest height reached by the stone is 34 meters. Let's move on to the next part of the question, which says that we should find the time it took the stone to reach the greatest height. As we saw from the previous slide, at this point, the stone has reached the greatest height. To find the time it took the stone to reach this greatest height, we have to trace this point to the t-axis, which will give us the time. On my graph sheet, the value of t at this point is 2.6. So we can say that from the graph, the time it took the stone to reach its greatest height is 2.6 seconds. Don't forget that t is in seconds, so the time is 2.6 seconds. Let's look at the last part of the question, which says that we should find the time it took the stone to hit the ground. So as we have seen, the stone started from the origin, then it traveled through the air and reached this greatest height. After reaching the greatest height, the stone will start dropping back to the ground. So from this point, the stone will now start dropping back to the ground. Remember that we said this horizontal major grade line represents the ground. So the stone will hit the ground at this point. The time at this point will give us the time it took the stone to hit the ground. At this point on my graph sheet, the time, that is the t value at this point, is 5.2. So we can say that from the graph, The time it took the stone to reach the ground is 5.2 seconds. So this graph helps us to analyze the movement of the projected stone clearly. It started at this point on the ground, which is the origin, 0, 0. It traveled through the air and reached this point, which is the maximum height. We have seen that the maximum height is 34 meters, and the time it took the stone to reach that maximum height is 2.6 seconds. Then from the maximum height, it started dropping back to the ground and it reached the ground at this point, and the time at this point is 5.2 seconds. So the maximum height reached by the stone is 34 meters. The time it took the stone to reach the maximum height is 2.6 seconds. And after projecting the stone into the air, it hit the ground after 5.2 seconds. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another likely examination question. Bye bye.